In exercise 1 through 4, evaluate without using a calculator. Use the Pythagorean identities rather than reference triangles. Find sine theta and cosine theta if tangent theta equals 3/4 and sine theta is greater than 0. And really the only Pythagorean identity we're going to need here is sine squared theta plus cosine squared theta equals 1. And I'm going to just, we're given this tangent theta equals 3/4, and so we're going to evaluate using this tangent identity, and sine theta over cosine theta equals tangent theta, which is going to be, we can rewrite as sine theta over cosine theta equals 3/4. And cross multiplying, we can come up with 4 sine theta equals 3 cosine theta. And solving for sine theta, we can divide both sides of this equation by 4. So we have the sine theta is equal to 3/4 of our cosine theta. So coming back over here, we're going to rewrite our identity, sine squared theta plus cosine squared theta equals 1. And we have one equation, but two unknowns here. But substituting to get one unknown, we're going to take where sine theta is and replace sine theta with 3/4 cosine theta. So here we are rewriting sine theta as 3/4 cosine theta, and I'm going to put squared on the outside, meaning that everything is squared, and that's what this notation is. And we bring down the cosine squared theta equals 1. And next we're going to go ahead and square inside parentheses. Well, 3 squared is 9, and 4 squared is 16. So we have 9/16 cosine squared theta plus, well, we're going to have to get a common denominator. Well, how many 16ths are there in 1 cosine squared theta? Well, there are 16 16ths. So we're going to rewrite this 16/16 cosine squared theta equals 1. And now we can combine like terms, and 9/16 plus 16/16 is going to be 25/16 cosine squared theta is equal to 1. And we're going to now get rid of this 25/16. What do we do to get rid of this fraction? Well, we're going to multiply by its reciprocal, which is 16/25. And we'll need to do likewise to the right side of the equation using the golden rule of algebra. Doing to one side of the equation what you do to the other. And we're going to cancel these reciprocals, multiply together, equal 1. So we have cosine squared theta is equal to 16/25. And we're going to take the square root of both sides of the equation, and we get cosine of theta equal to square root of 16, which is 4, over square root of 25, which is 5th, and that's going to be a plus or minus. But we know that the tangent is positive, we know the sine is positive, so therefore we're in quadrant 1, and the cosine of theta is likewise positive. So we have cosine theta equals 4/5. Now we're going to use this 4/5, rewriting this identity here, sine squared theta plus cosine squared theta is equal to 1. Well, cosine theta we've already defined and figured out that it's 4/5. So here's 4/5 replacing cosine theta, and we have sine squared theta. And what is a 4/5 squared? Well, it's going to be 4 squared is 16, 5 squared is 25, so we have 16 25ths. And we bring down the sine squared theta. And how many 25ths are there in 1? Well, there are going to be 25 25ths. And now to solve for sine squared theta, we're going to subtract 16 25ths from both sides of the equation. We have cancellation to equal 0. 16 25ths minus 16 25ths equals 0. So we have sine squared theta is equal to 25 25ths minus 16 25ths, which is going to be 9 25ths. And now taking the square root of both sides of the equation, we have sine theta is equal to the square root of 9, which is 3, over the square root of 25, which is 5, again plus or minus, but because we know that sine theta is greater than 0, sine theta by this reckoning has to be positive 3/5. So I hope this simplified using trigonometric identities has been helpful. Thanks for viewing.